Yeah, so I just wanted to share what I've been doing to do some planetary photography, kind of, well, partly in the hope of getting help to improve the pictures, and maybe some people might be interested in trying it themselves. Might be some useful websites and stuff that I found, hopefully. So I finally got myself a astrophotography tool. So I decided to get a DSLR camera. So I got this one here, the Canon EOS 5D Mark II, which is a pretty old camera now, but that means you can get it secondhand for a lot cheaper than a new one. So I got it from Park Cameras. It was £389, which is not a bad price, I think. The shutter count was 13,875 apparently, which seems pretty low. I've not checked that. I don't really know. Well, yeah, I probably can check that. I should check that. See if they're having me on or not. But yeah, so it seems like a pretty good camera. It was used, for example, to film an episode of the House TV program with Hugh Laurie. So it must be reasonably good. I decided to get a DSLR rather than like a planetary camera, webcam type thing, or a special deep sky camera, because I like the idea of it. One thing doing everything. I guess it saves a bit of money and it's just more simple. And so you can use a DSLR for deep sky and for planetary. And also you can use it for family photos, for example. If it's, like I say, used to film house. It looks like it takes pretty good photos as well. So I didn't want to have a modified camera where you modified a filter to let in the hydrogen alpha wavelengths, because then that makes daylight photos look weird. And so yeah, there's a kind of selling point to my wife as well, because she allowed her. It meant that she let me spend that much money on the camera if we can use it for family photos too. Though I haven't actually got a lens yet. It only comes as the body like that, so I need to get a lens before I can do that. Unless we take some very long distance photos of through a telescope. Yeah, so I chose this camera because it's supposed to be have good sensitivity to hydrogen alpha wavelengths. So that's 650 nanometers. So if you look at this curve here from the Colari Vision website, which gives you the transmission of different wavelengths, a percent transmission for different wavelengths. If you look at 650, then it's got about just under 30% transmission. So it's supposed to let just under 30% through, which is good for taking pictures of nebula, things like that. Compare that to, say, a Canon, let me get my pointer, to the other camera, this Canon T2i, and there's hardly any transmission at 650 nanometers. I've not tested that yet. People are saying that you can test it with a remote control to see if you can pick up the light from infrared remote control. So I'll give that a go and let you know. I'm kind of basing it all on this website. I don't know how trustworthy it is, but hopefully it's okay. And yeah, so a DSLR camera comes with lots of different settings here, and I've only actually used one of them, the M setting. I'm not even sure if that's it sounds some movie or for manual. I think it might be manual. So yeah, there's still lots for me to learn about this camera. So I've only used it about 4 or 5 times so far. And here's the telescope that I've got. I've had this for a while. It's a Celestron Nexstar 8 SE. It's a Schmidt-Cassegrain type telescope, an SCT. So the light comes in the front here and then bounces off the mirror here and then goes back up to a secondary mirror and then back down to the eyepiece. So that means that the light path is quite long. So it's got a 2-meter focal length. And the 200-meter aperture gives it an f10 focal ratio. So that's quite a high f value. So that means it gives you pretty good high magnification. So it's good for planetary work, but not so good for nebula, where you want a wider field of view. Currently, I'm using the 1.25-inch adapter for my camera, and then a Barlow lens for 2x Barlow is the only one I've got at the moment. And I'm using that eyepiece adapter to put the camera in there. I'm not sure if that's the best plan. I realized recently that you can unscrew the Barlow from the eyepiece adapter thing and put that onto the T2 mounted the camera, T2 adapter for the camera, and then I could put that straight into the back. So I don't know if that's any better. It'll affect the distance between the camera and the back of the telescope. So I'm Not quite sure what the effect of that is. You can also, you could get I've got a 2-inch adapter for the camera as well. So instead of using the 1.25, so I guess I get a wider, I'd use more of the, I utilize more of the camera sensor. So I guess with using the 1.25 inch, I'm probably losing some of the outer part of the image maybe. But, I don't know. I'm not too sure about all these things. Quite new to astrophotography. I've been using it in the start in the camera in the diagonal as well, like this, like one of these things here. I'm not sure if that makes any difference. So any advice on that would be appreciated. Just in terms of magnification, I was reading this article from Sky at Night for planetary work. This is so they've got this formula for what focal length to use for a given pixel size of your camera. So that's determined by your camera. So mine is 6.4 micron. So you multiply that by 206 and then divide by the desired arc seconds per pixel. So that value depends on the seeing. So if you've got really good seeing, you could use 0.1 in that formula, but I guess we don't get that too often in Britain. So 0.25 might be more realistic. And when I use this 0.25 value with my 6.4 microns for the camera pixel size, I get a 5.3 meter focal length. If I use the 0.1, I get 13.2. So currently I've got a 2 meter focal length. So that means a magnification of either 2.6 or 6.6. So I've currently got a 2 times Barlow. So maybe I could push that up to a 3 times Barlow to get 3 times magnification and to be consistent with this formula for the poorer seeing. And then maybe get a 5 times Barlow for if we get good conditions. So that's what I'm thinking. And yeah, so maybe I'll get 2-inch rather than 1.25-inch Barlows. So yeah, the idea with a DSLR for planetary imaging is to use what's called lucky planetary imaging, where you're trying to beat the poor seeing of the atmosphere. So the atmosphere is very turbulent, and that can distort the images and cause blurring. So for example, in this image, this is one of the first videos I took, or maybe the first one. You can see things are wobbling around all over the place. That's part of that's going to be the seeing. Part of it is quite windy. And it goes, you can see it gets lighter and darker, and that's actually clouds going over. So this is a pretty bad first introduction to planetary imaging. But I'm taking a video here. And the idea is that if you're taking lots and lots of images, then some of them are going to be when the atmosphere is quite still or there's not much movement, things are cancelling out maybe. So you get some images that in the movie that are reasonable. So apparently you want to do this as close to the camera's native pixel resolution as you can. And actually it disappears at one point. The tracking got lost. So I still haven't managed to get some image from this movie, actually. I'll show it later. Yeah, so, but if you use the normal movie mode of a camera, like the high definition 1080p, then apparently that resamples the image and you lose some of the fine detail. So what you do is use something called the live view from the camera, which is kind of what gets projected onto the LCD of the camera. And you can get that at a native pixel resolution of the camera then. So I'm using a software here called EOS Camera Movie Record, which is free, which is always good. And that captures the live view, and you can save to compressed AVI format, which you can import into Registax. And it can also control the ISO here and the what they call TV, which is the shutter speed. I think pretty sure it's shutter speed. So I'm not quite sure what the best options of these two are for planetary work. So this is Mars here. It seems like if you change one, you have to adjust the other one. So kind of balance between the two. So I'm not quite sure what the best combination is yet. And then with this software, you can also switch to 5 times zoom mode. And apparently you still get 1:1 pixel. You still get the native pixel resolution of the camera. So I need to do that for Mars really, because I think this is a 5 times view. It's pretty small if you don't do this. So I bought this camera I bought it because of the opposition of Mars when it was approaching. But that inspired me to do it, but then I missed it really by about a week or two. So I was pretty late. So by the time I got my camera and got some clear sky, it passed opposition. So I missed the best of it. But hopefully, yeah, I still plan to use it for other planets like Jupiter and Saturn, for example. So here's just an example. movie I made. This is one of the first better ones I made on the 30th of November. ISO is 640 and I'll do 180th shutter speed. So it's still pretty wobbly. You can see this is a map of the jet stream on that day, and it's bang over Britain, as it often is. But you can make out some detail, I think, some of the darker bit at the north and lighter bit at the south. And then that's probably wind making it judder, and then it starts to lose tracking. But I'll show you the final image I get from this video later. So I've been using Registacks to align and process the images. So even though it's wobbling all over the place in that image, in that video, just even moving away from the center, Registacks can track the image. So it uses these align. So you can set it. Press this button here, set align points, and it creates some align points on Mars. So on Mars, you get about 10 or so, but you can increase it. But I think 10's about right for Mars, apparently. And then so it takes all the frames. So it examines each frame of the video. So I've got 5,000 odd frames here from this movie, and it picks out the best ones and it centers them all, so they're all centered on the disk of Mars in this case. And you press, you do that, and then you press this align button somewhere here, and that can take quite a while, maybe about 10 minutes, 5-10 minutes. And then the next stage is you can limit, so it picks out the best frames, so you can limit the images it uses to say the best 10%, for example. So I had over 5,000 frames, which is about 4 minutes for this one. I picked the best 10%. So you click limit and then you click stack. And then it stacks all those best ones together into one image. And then this is what I've got here. Yeah, this is the resulting image. So it still looks quite blurry. And it kind of looks, I guess it's obviously better than the movie, which was moving all over the place. But then you've got these things called wavelets, which is in Registacks where you kind of can sharpen or denoise the image. So for example, using these settings here, there's like 6 different sliders. It seems like a bit of a black art as to what these actually do and how to get the best result, and it varies from image to image. I'm not seeing anything definitive on how to do that, how to best do that. Well, the websites mainly do often say it's just an art, just kind of try different combinations and see what's best. So here's one where I've sharpened the image a bit and made it brighter. It's got some options where you can automatically equalize the histogram to make it brighter, and you can correct for the color aberration as well, the red-blue aberration that you often get. It seems like sharpening brings out the detail, and then you have to denoise to kind of balance out the effects of that. But I'm still experimenting with this. But anyway, this is the kind of image I got from that video. So it's quite a bit better than while just looking at the video. It's not the best image of Mars, but we're getting a lot of this brightness around the edge. I'm not sure what's causing that. It seems like that gets brought out more by the sharpening. So here's some more results. This is from the same images that I just showed, same video that I just showed. This is the stacked image. Then you do the wavelet sharpening, and then you can do even more sharpening, but it looks a bit unnatural. So you maybe get more detail in the middle, but you get this brighter halo around the edge. And this is what it should look like according to Mars Mapper. So it seems like it's reasonably close to that. You can see the dark area in the north and brighter area in the south, maybe a hint of the polar ice cap. So yeah, it's not too bad for an early attempt, I think. This is just, so I was a bit surprised actually. This is from this guy's website, is Jerry Rodriguez, I think. He seems to be all over the internet about this kind of planetary imaging. And even in his images, he had this is a stacked image after the limiting and the picking out the best frames and stacking them. So there's not much detail there, but then when he does a sharpening, he seems to bring out an amazing amount of detail. So it seems like this phase going from stacking, the sharpening phase, that seems to bring out most of the detail. So I guess maybe I need to learn to do that a bit better. But I think I'm not helped by the poor seeing in a lot of these videos that I've made. Yeah, so I guess presumably the stacking phase is just needed to. If you did the stacking, the denoising on a single video frame, then I guess you wouldn't get good results. But it seems like a bit a magic step between this stacked phase and this sharpening phase to me. So here's just a collection of images that I made from November. I've not had a chance in December. So this is one of my very, very early ones. So you can see it's not too great, but there is some similarity to the Mars mapper image there, dark and light. And then 21st of November, all different ISO settings and different shutters, experimenting with those as well. You can maybe see a bit more detail here in this nice dark bands, which is similar to what is in the mapper. Actually, I seem to have picked Mars, each tower seems to have a similar side of Mars with Olympus Mons in the front. Maybe this one's a bit different. And this one, 25th of November, this is with a lower amount of sharpening and a higher amount of sharpening. So I'm not sure if that's maybe too much sharpening. It seems to have brought out a feature down here, which does actually correspond with Olympus Mons, but I don't think it is. So I'm not sure if that's a real, that blob there is a real feature or not. And then this is a later one, 30th of November, a bit like the one I just shown, but a different video. Maybe that's a more natural looking one, but maybe a bit less clear. We've still got this kind of crescent-y light bit on the left side there. Now in each of these cases, this is a jet stream in over for each of those days, and you can see it's the jet stream is always over us for all of these images. So maybe I've just been unlucky, or well, I think it's just called living in Britain. It's obviously not the best place to do this. And then as well as Mars, I've been looking at, done a few moon images as well. This is the same image, but with lesser and more sharpening. I'll let you decide which one looks the best. I guess this one, I guess the left one looks more natural, but the sharpening you do see in more detail. So these are quite wide angle views now without the 5x zoom mode. And this is one of the, I should have looked at the names of these, but I quite like the fact that you can make out this crater looks quite 3D. Looks like a big volcano almost, and then you can see the mountains on the edge, the limb, quite nice. But then there's also this weird kind of effect around the edge from sharpening. I'm not sure. Yeah, I don't know what that's all about. It's just a full disk image of the moon. So I think I've got a filter on here, number 11, so that's probably why it's a bit dimmer. And same with this one, that's why it's a bit yellowy. I think I was experimenting with filters for Mars and left it on for the moon. But yeah, I guess you can see some kind of 3D lumps and bumps over here, which is quite nice. And over here. Yeah, it's always the edge that looks nicest. And this is a close-up of the limb. I quite like these craters over here. Oops. Oh, this has gone weird. And then here's a closer image of these craters, which I thought were quite nice. I did look this one up, I've forgotten. There's an interesting little line of craters here. So you see, I guess you pick up some detail that you might not notice through the eyepiece when you come and look at them again. That's quite nice. And you can see these rills here in this sea. And then this is quite a famous crater. I think it's Copernicus, is it? I've forgotten. Yeah, there's quite a high rim here. Brought out quite nicely, I think. And then this one, it's one of my favorites. This is actually a picture of my son's football in the garden when it was snowing. But I happened to see it when I was doing planetary imaging, so it reminded me of what the images I was trying to make. And then yeah, so I guess wondering about ideas how to improve, particularly the images of Mars, maybe. Although maybe it's well, I could get a 3x Barlow, giving more magnification. Although I guess it's getting smaller in the sky now, so as time goes on, so maybe that's maybe it's time to move on from Mars. And the more magnification you get, the more limited you are by the seeing as well. So yeah, I guess the next point is try and get better seeing. Just try more often, and hope the jet stream's not over us. There's various different live view software capture. Live view capture software you can use. I use this one, but there's Fire Capture, Sharpcat, Images Plus, Backyard EOS, Astrophotography tool. And I know that, so EOS does compress AVI. I don't know if that makes a difference. Possibly not, but if you don't compress it, you have massive files. There's a downside. And the telescope seems to be affected by wind quite a lot and vibrations. Maybe if I put it on so I've been doing it on the paving at the moment because the lawn's too muddy. I don't want to trample mud in the house when I'm in and out. So I've been trying to avoid the lawn, but I guess the lawn is going to be less prone to vibrations. And I've heard you can get anti-vibration mats, or I've heard putting squash balls on the tripod legs might help. Might be act as an anti-vibration method. Someone online was talking about when they do this, they get some software that crops out the image of the planet and centers that before it goes into Registax. So I'm not sure if that would help. Registax does seem, if you can create an image, a movie of the best frames that Registax finds, and they seem pretty steady in the middle of the image. So I think Registax maybe does a good job. Anyway, and people say that collimation is important. So I've never collimated my telescope, so I'm not quite sure how to do it. So maybe I should look into that. And then maybe it's a good idea to focus on the stars before moving to the planets. Focus on the stars and then image the planets because you get a better focus. Or maybe get one of those Batinov masks. And then, I also plan to move on to Jupiter and Saturn, especially with the conjunction coming. So Jupiter especially is going to be bigger. So hopefully that will just make things easier and get some nicer images just because it's bigger. And these are just some useful websites that I found just for reference in case anyone wants to copy this presentation. Okay, that's just some quote I found. In terms of whether to use, how to balance the exposure time versus the ISO. I think it says for the moon, you probably want a low ISO, and then you just mess around with this shutter speed. Yes, that's about it. That's all I was going to say. So any advice is appreciated if anyone's. Well, I guess Rod's going to talk in a minute, so maybe he'll enlighten me on some of these things. So any questions or anything or comments?
Dan, the software you want for cropping, it's PIPP, I think it's called. It's really good. It's free. I use it for the space station. And it goes through, for mine, because the space station is moving around all over the place, the setting for the space station goes through and removes the frames that are empty and then centers the rest.
Okay.
But you haven't got that. You've got something relatively still, so it will crop and center. I think it's planetary imaging preprocessor or something it's called. I think that's what it stands for. And it's free, and I think it's superb.
Okay.
From what I can gather as well, it's specifically meant as a preprocessor for Registax.
Okay. You never tried it on Steve for planetary?
Yeah, well, I mean, one of the things I'm amazed you managed to get Registax to process a 4-minute clip.
Yeah.
The minute that I try it just hangs. So,
yeah, I've had a few times where it's crashed.
Yeah. So I use PIP just to kind of cut it down, just say cut it down to the best sort of 25%. And then I get a shorter clip, which I then throw at Registax.
Okay.
Yeah. But I mean, those pictures that you got there, they were good. So I mean, from my point of view, the main thing you need to do is just keep trying and playing around. The more I've done with the camera and tried various things, but the more I've found out.
Yeah, just keep trying. Oh yeah, okay, yeah. So do you does it make much difference how far the camera is from the telescope in terms of whether I use this Barlow eyepiece adapter or versus straight in the back?
Well, if you're taking pictures of the planets, you're going to want magnification. So I mean, when I took my pictures of Mars, I was using two Barlows plugged into each other. They were only 2 times Barlows, but any smaller than that, it was just so you know, any less than that, it was so small, it didn't seem worthwhile.
Yeah, yeah. That's the thing, isn't it? How do you stack? You just put the Barlows together like 2 eyepieces, like you would 4 eyepieces.
Yeah, but I mean, one of the Barlows kind of goes into the T-ring in the camera, and then I just put that into the other Barlow, and then that into the telescope.
Yeah, okay. Yeah, I noticed recently you can unscrew it and put it onto the T.
Yeah.
Yeah, small Barlows would be good. Christmas present. Christmas list.
If you're taking pictures of nebulas and things, you're probably going to want to try getting your camera directly hooked up to the telescope.
Right. Otherwise, you don't get as wide a field of view.
Yeah, I mean, it depends what you're after, but yeah, because I mean, have you got a 2-inch eyepiece in your telescope?
No, I haven't got any of those.
And in that case, then you're going to have to stop it down anyway.
Well, I've got a 2-inch T2 for camera, so I can.
Yeah.
It's got a 2-inch optical back.
Right.
So I can plug a 2 in.
Would your telescope take a 2-inch eyepiece?
Yeah. Sorry, yeah. I just haven't got any. Yeah. But I don't need the eyepiece to.
Just because you'll just get more detail in your picture. You get more on your picture.
Yeah. I was hoping to try that. But I haven't got a Barlow to do that. So you couldn't do that with a Barlow. Yeah, I think I need the Barlows. So I'm going to get some 2-inch Barlows.
Right. But I mean, really, I think you need to play around and practice.
Yeah.
Is everybody hearing strange noises?
Yeah.
Lots of feedback.
Are they having a problem with their system? Thank you very much, Dan. You actually covered a lot of what I was going to do.
Right. I was worried about that.
Just a bit whilst you've got the PowerPoint on. The right-hand picture, you're wondering why it's got a big bright rim to it. I did notice, I don't think you can get back to the slide that has the wavelets.
Yep. There.
And I noticed that your bottom one was turned up to 100.
Oh, yeah. I don't think I always have that on.
Sorry, Rod, I think I've just muted you. Let me just get you back.
Yeah, I think that was. I think I still get that even without that on, but I'll double check. What were you going to say, Rod?
Sorry, I didn't realise I was muted.
Yes, sorry, Rod. I clicked on it by mistake.
That slider that's on at 100, in fact you got 2, but especially the bottom one, that would do that effect. In fact, it's amazing that you've got anything at all. If that was what you've actually set them to for that particular image, I'm very, very gentle with those numbers and very rarely go above 10 with anything.
Okay. Yeah, there's so many combinations, aren't there?
Yeah, but that is the sort of thing that it does if you go too far. I don't know why we've lost the echoes. It would be an interesting thing to find out.
I've muted everybody one by one apart from us, so apologies to everyone else.
Right. Thank you very much for that, Dan. That was excellent.